The title of our project is Breaking Domain Barriers, Hybrid Pso-Cnn for Next-Gen Sentiment Analysis. We are from University Technology Mara, Malaysia. What is sentiment analysis? Why is cross-domain sentiment analysis challenging? Why are hybrid models promising? Sentiment analysis helps us understand opinions in reviews or social media posts. The models usually perform well only within their training domain. However, when applied to a different domain, accuracy drops significantly. For example, the performance drops when a model trained in one domain is applied to another, like books versus DVDs. Our work proposes a hybrid optimization and deep learning PSO-CNN model to overcome this challenge. This project is driven by a simple yet powerful goal: to help sentiment analysis models adapt better when applied to new domains. We do this by using particle swarm optimization to fine-tune CNN hyperparameters, making the model smarter, more flexible, and more accurate across datasets. Let's move on to the methodology. We used a benchmark dataset by Blitzer et al. For this study, we focused on just the book as the source domain and the DVD as the target domain to perform cross-domain sentiment classification. After selecting the dataset, we pre-processed the text. Next, we tokenized the text, turning the reviews into sequences of numbers, and padded them to a uniform length. Finally, we extracted sentiment labels. For model development, we used a CNN, convolutional layers extract features by applying filters that detect patterns like edges and textures. Pooling layers help reduce the size of these feature maps, which lowers computation. Then, fully connected layers classify the sentiment using the learned features. The PSO hyperparameter settings used in this study are summarized in Table 1. Result and discussion. The first one, PSO for hyperparameter tuning. The algorithm is executed for 10 iterations with the parameters C1 equals 0.5, C2 equals 0.3, and W equals 0.9, where cognitive coefficient, C1, represents the particle's experience influence, social coefficient, C squared, represents the influence from the swarm, and W inertia weight helps balance exploration and exploitation. The next one, model evaluation. A neural network model is first trained on a source domain dataset consisting of book reviews. The training spans 10 epochs, and the model's performance improves significantly over time. The model learns well on the source domain but might be at risk of overfitting due to its perfect training accuracy. Refer to the model's performance on the target domain below. Test accuracy 71.50%, precision 0.7143, recall 0.7214, and F1 score 0.7178. The last one, ablation study. An ablation study is conducted to evaluate the impact of different architectural choices on model performance. The figure shows the accuracy comparison for the ablation study. When dropout layers are removed, the test accuracy improves to 73.25%, suggesting that dropout may not be essential in this setting. However, removing pooling layers causes accuracy to drop significantly to 60.75%, highlighting the importance of pooling for feature extraction. A baseline model is also trained for comparison, achieving an accuracy of 68%, which confirms that the optimized model outperforms simpler architectures. This slide shows the model development process for the hybrid PSO-CNN model. The notebook displays multiple training epochs with corresponding accuracy and loss values. We used TensorFlow and Keras for model training and evaluation. The study demonstrates that PSO-CNN hyperparameter tuning effectively enhances model performance, and transfer learning enables adaptation to a new domain. The ablation study highlights the importance of pooling layers, while dropouts' effectiveness varies based on the dataset. Future directions include the integration of other bio-inspired algorithms like GA and ACO to further enhance model adaptability and generalizability in multilingual and noisy datasets. This extended research is based on our published article in IEE titled Hybrid PSO-CNN Model for Cross-Domain Adaptation Sentiment Analysis. The paper was officially published in 2024, and you can access it through the link shown on this slide.